back. This is problem 3 of section 3.4. You want to evaluate the following limits. Okay. Enter INF for infinity, MINF for negative infinity. Okay. Limit x approaching infinity, radical x squared minus 2x plus 1 minus x. And limit x approaching negative infinity of square root x squared minus 2x plus 1 minus x. So the same expression. This one is limit x approaching positive infinity. This is x approaching negative infinity. Okay. So what is the situation here? Look, the problem is if I plug in x equals infinity, always in an expression like this, look, there's no numerator, denominator. No matter what your expression, first figure out, have a sense of what this would look like if x were a large number. So for the sake of argument, let's take x to be, say, 1000. Then 1000 square is a million. No, is it a million? It is a million. Then minus 2000. So a million stands out in comparison to 2000 plus 1, right? So a million square root gets me, so this is basically approximately back to being 1000 minus 1000. You see? Now all that starts, so it looks like to me infinity minus infinity. That's a big no-no. Infinity minus infinity is not something we can surely say is a zero or an infinity. We cannot say that. In other words, so let me go back. Let me say a few things. Infinity times 0 is a big no-no. That means we don't know what its value is. So if you substitute things and you come across infinity times 0, it means you need to do some manipulations. Likewise, if you come across infinity minus infinity, that's a big no-no. You need to do some manipulations. Infinity over infinity, again, not acceptable. Some manipulations, 0 over 0, not acceptable. What is acceptable? Infinity times infinity. It is an infinity. Okay, this is okay. Infinity plus infinity, that is another infinity. That's okay. Just as 0 plus 0, 0 times 0. These are things you know. All right. Coming back to our problem. So looks like if I plug in x equals infinity, I get an infinity minus infinity, which is not acceptable. I need to do some manipulations. So let's try. Because I don't have any denominator or anything to cancel things with, I will take the conjugate of this expression. Where I have a minus, I replace it with a plus. That's all. Multiply the numerator and denominator by the conjugate. Always with a radical, conjugate method almost always works. Okay. What's the purpose of the conjugate? Well, difference of squares. Something minus something, something plus something. So difference of squares. Square of the first minus square of the second. Denominator I haven't changed. Remember, this was the conjugate. Okay. All right. Square of square root is, they cancel each other. You have x squared minus 2x plus 1 minus that x squared brought in as it is. So x squareds cancel. You're left with negative 2x plus 1 upstairs and all of this downstairs. This was the conjugate that you multiplied with. Okay. Now look at the highest degree here. It's x. Look at the highest degree here. It is also x. Square root of x squared is also an x. So the highest degree is actually x. So divide the numerator by x, divide the denominator by x. Division distributes. So this x goes here and here. 2x over x is 2 and 1 over x. All right. Likewise, this x in the bottom distributes. 1 for the radical, 1 for the sole x over there. So square root x squared minus 2x plus 1 over x plus x over x is a 1. Now x is going to infinity. In other words, x is greater than 0. So square root x squared is x. In other words, I replace this x by square root x squared. Okay. Which brings me to, so this is a standard trick. When you're dealing with a square root x squared upstairs and an x below, this is almost always the trick you choose. So now you can combine the two square roots into one. I have not changed anybody else. So these two combine into one square root, x squared minus 2x plus 1 over x squared. Okay. Now division distributes again. X squared over x squared is a 1 minus 2x over x squared. You see, one of the x's cancel, negative 2 over x, and then plus 1 over x squared. Finally, you're ready to let limit go to infinity, positive infinity. This quantity goes to 0, this quantity goes to 0, this quantity goes to 0. You're left with negative 2 upstairs, square root 1 here, plus 1 here. Negative 2 over 2 is negative 1. Okay, you came across a pure number as opposed to infinity minus infinity. So I repeat, if you come across infinity minus infinity, it is not a 0. It means you have to do some manipulation. And as in this example you did not get a 0, you got a negative 1. So let me go back to my problem. It's a negative 1. Okay. Now let me take limit x approaching negative infinity of the same expression. Okay. X approaches negative infinity of the same expression. In this case, mind you, let me try. You see, if I plug in negative infinity, looks like I get some kind of, when I square the negative infinity, it becomes positive infinity squared. And I take square root, so that gives me some kind of positive, I hope you can see what I'm saying. I'm going to get some version of square root of infinity square plus some things inside. Okay, I don't care about them. On the other hand, what is this? Minus of negative infinity. Do you see that? So this looks promising because this looks like to me an infinity. Okay, this looks like an infinity plus an infinity situation. Okay, it looks promising. That negative and a negative, that negative with a negative infinity. So this is something we are talking among friends, okay? So I cannot simply write such nonsense. I'm just letting you know intuitively, this looks like a good problem. I don't need to manipulate. So I don't need to do any conjugation or anything of that kind. So let me try to work within what I have. X squared, I'm writing this expression under the radical as x squared 1 minus 2 over x plus 1 over x squared. In other words, I got x squared out. How do I get it out? I divide this by this, I get a 1 inside. I divide this by this, I get 2 over x inside. I divide 1 over x squared, I get 1. Why do I do it? Check. X squared times 1, I go back, I get x squared. X squared times 2 over x, I get 2x. X squared times 1 over x squared, I get 1. So this expression is same as this expression. Minus x, no change there. Square root of x squared. Square root of x squared is negative x. Why did that happen? Well, because I'm negative. My x is going to negative infinity. When x is negative, square root of x squared is negative x. This is a standard trick. All right. So, square root of x squared is negative x. I have just rewritten it. Okay. Aha, this is getting even better because I have a negative x here and a negative x here. They are common factors. So I pull negative x out. What's left inside? All of this expression plus 1, because negative x got pulled out. So plus 1 is inside. Okay, multiply it and check for yourself. Now when I let x approach negative infinity, negative x becomes positive infinity. This quantity goes to 0, this quantity goes to 0. Square root 1 is 1, plus 1 is plus 1. So positive infinity times 2, that is a positive infinity. So let me write it here in INF for infinity. Submit. It's good. All right. Until next problem. Bye.